You're probably familiar with using Redis as a cache and a database. Maybe you've even used it for messaging and streaming. But did you know you can also use it to serve up AI models and put them in your application? Sounds crazy, I know, but it's true. And Redis AI, it's the magic that makes this possible. Stick around to learn more. So there are a couple of patterns for hosting models and making inferences from your application. We're going to look at those first. Then we'll also look at how to host and infer using Redis AI specifically. And finally, we're going to share the particularly unique advantage that Redis AI gives you. Spoiler alert, it's data locality. Deploying models so that engineers can put them in applications is, shall we say, a non-trivial problem. There are three basic patterns to solve this problem. The first pattern is to just make the models a part of your application. Applications often ship with all sorts of binaries and libraries. The model on the backend to serve it can just be another one of those binaries and libraries. No big deal. This works, of course, but the brutal simplicity of it has some major drawbacks. First, it tightly couples the model to the application. Changing the model means redeploying the application. Changing the application means redeploying the model. This pattern can also lock you into restrictive sets of technology choices. If you're using a tech stack that's incompatible with your data science stack, you've got a problem. Another common pattern is to build a small service around the model and then containerize it. This actually works pretty well. It reduces the coupling between the model and the application, which allows you to deploy updates to the model without updating the application that uses it, and vice versa. And this pattern allows you to use whichever tech stack makes sense for your application, rather than letting the availability of a certain machine learning library dictate your stack. However, it does mean that your models are accompanied by small one-off services. And if you have lots of models, then you can have a lot of one-off services. And this can be difficult to manage. The third and best solution is to use a purpose-built model server. Model servers live to host models and provide a common service interface for applications to consume. They eliminate the need for containerizing models while still providing that loose coupling between your model and your application. And this is where Redis AI comes in. Redis AI, it's a module that gives Redis the ability to host models and perform inferences. Redis AI makes Redis a model server. Redis AI works by introducing two new data structures for use with AI: the tensor and the model. A tensor is a data structure that represents a multidimensional array of a particular numeric type, like a float or an unsigned 8-bit integer, in other words, a byte. Your tensor could be a simple one-dimensional array or a complex 37-dimensional array. The shape of that tensor is how wide it is in each of these dimensions. Tensors are used as the inputs and outputs for inferences that we make using Redis AI. A model is a data structure that contains an AI model for a particular backend, such as TensorFlow, PyTorch, or ONNX. Models are the things that do the inferring. They take one or more tensors as input and produce one or more tensors as output. Putting these two structures together, we can perform inferences. Let's look at a hypothetical example where we're a bank that wants to determine if we should give a loan to an existing customer or not. So the first thing we need to do, and before we can do any inferences, is we need to load a model into Redis AI to do the inferences. This is setup work, and so we only need to do this once at the beginning. Our hypothetical model expects two tensors as input: a tensor containing the details of the loan, like the term, the rate, and the principal, and another tensor containing our customer's banking records. We can upload the data for both of our input tensors, and then ask Redis AI to run the model, performing an inference against them. Redis AI then writes the results of the inference to an output tensor, which we can then read to get the results. And that works pretty cleanly. But there's an interesting detail. We have two sets of data: the loan details, that desired rate, term, and principal, and these are entered by the user, and the customer's banking records, which are not entered by the user. Instead, the banking records need to be retrieved from some sort of data store that is probably elsewhere on the network, and possibly on disk before it can be placed in Redis. Making this network call and doing this disk read incur costs that slows down the entire process. But, and this is important, Redis is a data store, an in-memory data store. And if our customer's banking records are already in Redis, the retrieval step can happen within Redis. No network, no disk, just memory. This is called data locality, and it gets us a huge performance boost. So how do we take advantage of data locality with Redis AI? After all, while a customer's banking records might be in Redis, they probably aren't stored as tensors ready to go for a particular model. Well, that's a big question, and a topic for a future video. But the short version is that we use Redis Gears, which is another Redis module, to load the data you already store in Redis into tensors for a model to consume. So let's go over what we just covered. We've talked about 3 different model serving patterns, with the clear winner being a purpose-built model server. We've talked about how you can use Redis AI as that model server, and we've talked about how you can significantly improve the performance of your inferences by taking advantage of data locality. So that's a lot. If you'd like to dig a bit deeper with Redis AI, there are several links in the description below. Go and check them out. And of course, we've just scratched the surface on what you can do with Redis AI. Expect more videos on Redis AI in the future. And make sure you don't miss any new videos by smashing that subscribe button and ringing the bell. Thanks for hanging out and learning about Redis AI.